everyone, welcome to chapter 3. In this chapter, we would like to talk about what are abstraction, what is modularization, how to do object creation, how to create object diagrams. We will also use method calls and debuggers. In our previous chapter, we have examined what objects are and how they are being implemented. Now we are going to actually take it further. We are going to look through an example, which is the clock example, a digital clock. And we will talk about the interaction of the object, which is a display for a digital clock. So in here, as you can see, that the display shows the hours and minutes. And actually, it is separated by the column. For this exercise, we are going to build a clock with the 24-hour display, like the European style. And then the display will show the time from basically midnight to 23:59, which is 1 minute before midnight. So just in this example, I just want to emphasize that we are not going to build a 12-hour clock, which is a little bit more difficult than being the 24-hour clock. So we are going to actually focus on the 24-hour clock. We will actually going to talk about two important concepts here, abstraction and modularization. Before we implement this clock, the first thing that might come to your mind is that you can just display the clock in a single class. And you have kind of learned how to build the class to do that. But we're just going to take this problem a slightly different way. So what we are going to do is that we are going to actually look at this by going through ignoring a lot of details and focus our attention on a higher level problem. And we are going to use the abstraction methodology. So what we are going to do, we are going to divide the problem into sub-problem and again break them down further into smaller problems until the individual problems are very small to deal with and it's easy to tackle with. So once we solve one sub-problem, we don't think about the details of the other parts anymore, but we treat the solution as a single building block for our next problem. So this technique, sometimes we might call them the divide or conquer technique. So let's just take this example. Like imagine that you are the engineers in a car company. They are designing basically a new car. So they might actually, each engineer would think about different parts of the car. So some parts could be maybe the shape, the engine, the size of it, maybe the size of the passenger seat and things like that. And another engineer might actually think about the actual parts of the engine, such as cylinders, the injection mechanism, and etc. So each engineer will be actually designing that just one part that they have. Each engineer will focus basically on some part of the design. So maybe one person will just design the interior passenger size of the car, and somebody else maybe develop the cover seats or something like that. So it is actually impossible for a person to actually be designing all of these parts of this car. So different people are going to be focused on different part of it. So the reason why these car companies are kind of successful is that the engineers, they use modularization and abstraction, these two concepts that we are talking about. Basically, the modularization is the process of dividing a whole into a well-defined parts, which can be built and examined separately, and then they can interact together in a very well-defined ways and manners. So just one last difference between the abstraction and modularization is the modularization is the process of basically dividing large things into smaller parts, versus abstraction is the process of ignoring the details to focus on the bigger picture. So let's look at this clock display example. By using our abstraction concepts that we just talked about, we can actually look at this example this way. One way is to look at it, consider it as consisting of a single display with 4 digits, 2 digits for the hours and 2 digits for the minutes. Or another way that we can actually look at it, two separate 2-digit display, one pair for the hour and one pair for the minute. So one pair could start at 0 and increase by 1 each hour and then rolls back to 0 after getting to its limit of 23. The other rolls back to 0 after it is reaching the limit of 59 seconds. The similarity in behavior of these two displays might just lead us to abstract away even farther from viewing the hours display and minute display distinctly. So we can actually think maybe as these being as objects that can display value from 0 up to a given limit that we have. And the value can actually be incremented. But if the value reaches the limit, then again it goes back to the 0. So that's kind of a abstraction that we want to look at in this example. So we can basically program this as a class for a 2-digit number and then give it access the accessor method to get its value. And 2 muter methods set the value and to increment it. Once we have defined this class, we can then just create the object of the class with different limits to actually construct the entire clock display. So let's look at it in this example, how we are actually going to implement this the clock display. So we said that we are going to build a 2-digit number display. So basically this display needs to store 2 values. One is the limit to which it can count before rolling over the 0, and the other is basically the current value. So we can actually represent these as integer field. So as you can see here, we are going to actually use our class, the name of the class, number display. And then we will think about the clock display. We will think in more complete terms. So for this, we will actually going to display the class number display as integer limit and also integer value. And for now, we are just putting the constructor and methods. We are omitting it. As we have discussed the fields in chapter 2, we said that the word private in the field declaration is actually followed by a type and name of the field. So the type is integer and then the name of the field, which is limit. So we have for our number display, the field would be basically will be let me just show you. It would be actually for the clock display, it would be the hours and it would be the minutes. So this is actually the clock display, and you will use the name clock display as a class name. And again, same as we did before, we use the word private and we use the class the number display, and the field would be hours, and then again we are going to use that class that we just defined over there, and the field would be minutes. Let's look at the class diagram versus the object diagram. So in this diagram that you can see, this is basically the object diagram, which will have the number display as one of the fields, as we said for the hours, the field hours, and then the field minutes, as you can see in here. So in here, you can see that the object diagram shows 3 objects, as you can see in this example. So as we have talked in chapter 2, we can actually create multiple objects from the same class. So we can create 2 number display objects from the number display class. So we have 2 objects. We could have multiple objects from the same class. So number display and number display. To start the program, we can actually create an object class clock display. We will program the clock display so it can automatically create 2 number display objects for itself. So if we just look at the next diagram, you can see that the class diagram here only shows 2 classes, the clock display and the number display. But as we said, the number display can have, it has 3 objects, as we can see in here. Another thing that maybe we can see from this object display is that a variable stores an object. The object is not stored in the variable directly. So as you can see in these white fields, these white boxes actually, these are the variables are being showed in here. So when a variable stores an object, the object is not stored in the variable directly. It is actually object reference that is stored in this variable. The object referred to it as stored outside the referring object, and the object reference links these 2 together. It is very important to be able to actually draw these diagrams or maybe have them in our head to be able to understand the class diagram, the relationship between these classes, and then of course the object diagram. It's very important to understand this if we want to understand the structure of Java. Java has 2 very different kinds of type, the primitive type and object type. The primitive types are all predefined in the Java program. They can include both integer and Boolean. So we can find a complete list of this in the Appendix B of this book. Object type are those defined by classes. Some classes are defined by the standard Java system, such as a string, for example. Others are those classes that we actually write ourselves. So both primitive types and object type can be used as type. So before we start analyzing the source code of the full clock display project, it will help us to understand the number display class and how it can actually support the clock display class. So the constructor for the object of class number display set the limit at which the display rolls over. So that's what we have here, the limit that is actually rolls over the limit, and the value start from 0. And of course we will have the increment here. So in here we have the increment display the value by 1 and rolling over to 0 if the limit is going to be reached. So value plus 1, and that's what we have it in this example. So by looking at the source code, we can see the constructor received the rollover limit as a parameter. For instance, if the 24 is passed in as a rollover limit, the display will roll over to 0 at that value. The range for display value could be from 0 to 23. So this feature basically allowing us to use this class for both hour and minutes display. For the hour display, we can create a number display with limit of 24. For the minute display, we can actually create one with a limit of 60. So the constructor stores the rollover limit in a field and set the current value of display to show as 0.